The rest of you, in your notes, because this won't fit on the whiteboard, and I want us to get a little bit beyond just here's a function differentiated today, although that is what your homework is going to mostly be. There's a monstrosity. I've decided I like 3 today. Think about how you would attack differentiating this. Before you say, oh, this is too much, just go term by term. Do you know what to do with this term? Yeah, you do. You know what to do with this term? You can probably figure out how to rewrite it so that you can differentiate it. So go through term by term. Where you need to rewrite the term before you differentiate, and then take the derivative of each term, and the derivative is the sum of all of those derivatives. So you might look at this and say that's just awful, but if you look at each individual term within itself, it's like, well, that term's not so bad, and that term's not so bad. Okay, that term's kind of a jerk, but I can deal with one jerk, and see how you do with it. Yes, ma'am. Maybe. Yeah. So if we use the ddx notation, we can almost put brackets around the thing, get differentiated by cell. So that's kind of good separating off things that have. George. Distinguish between a constant term and then just a number that's multiplied. That's cool. So like 37, the 4 is a coefficient multiplied. So it doesn't. But in number 1, big ugly up there, 3 at the end is a constant term. So then differentiate it. All right, so let's go over the 2 homework problems we have up here, 24 and 37. 24, who are you? Laura, please talk to us.
Okay, so we're looking at the but what I did is I was having a problem where I added 1 to the last 8, then 6 to the outside, X minus 6 is now on the outside. And I just have to turn it to start it to do my something. And then the turn it to be opposite, and just put the back at under, under at 1, and then from our special rules that we had, it would become minus 2 sine x, and I just left it as that, more.
And there's always, I suppose, more you can do, but you don't want to. So no, that's plenty sufficient. That's great. All right, so rewrite the first term. Since the whole 2x has the exponent, apply the exponent to the entire denominator. 2 cubed is 8. And then x has to get out of the denominator in order to be allowed to do power rule. Then you do your power rule, multiply the exponent down in front, so you get negative 15/8. Subtract the exponent by 1, you get x to the negative 4, and then throw them down the stairs to make them a positive exponent. And that term's done. Over here, derivative of cosine is negative sine, and you're multiplying by 2, so negative 2 sine. Any follow-up in 24? All right, 37. was Raisa, talk to us. Ta-da. And you could label this as either f prime of 0 or m, because they're the same thing. So that's great. So again, you're differentiating each term separately. And for those of you like, what do I do with this thing? Theta, is he a constant or a variable? He's a variable. He's got to be one or the other. And he's not a number, and it's not like pi, so it's a variable. And what's theta's coefficient? And what's theta's exponent? And if you do a power rule, multiply the exponent down in front. -1 times 1 is -1. You reduce the exponent, and you get theta to the 0, which means no more thetas. It's just the 1, because that's 1. So you end up with -1 times 1 is -1. So if you have a variable all by itself like this, and you take the derivative of that, remember this is 1x to the first. And so this guy's derivative is 1. Not to be confused with a constant, his derivative goes, poof, 0. Any questions to follow up either of these? So back over to here. How are you guys coming along with number 1? Done? All right, cool. Keep working on it. If you're done number 1, I'm going to come around and check. Call me over and I'll come and check it. And then try 2, 3, and 4. 2 and 3 both require some moderate rewriting before you're allowed to differentiate. And keep in mind, with something like 3, who's getting divided by x cubed? The whole thing. So when you rewrite it, remember, you're dividing the whole thing by x cubed. So this is x squared divided by x cubed, and also this guy divided by x cubed, and also 1 divided by x cubed. So it's basically distribution of division is what's going on in 3, just like this is distribution of multiplication. So I'll come around and check stuff and make sure you're comfortable with this, or at least maybe not comfortable, but competent.
Oh, okay.
Got all that.
Yeah.
So you got to divide this cube first, and then
How am I going to reach that? You kind of
it's like you just shoot it out, and then you got to shoot it out. And number 4 is good. Just don't lose your side function. It's sine of x, so it's good with this cosine of x. Any true function has some variable inside something. So yeah. So then reduce each of these things so that it's like a single x somehow. X squared divided by x cubed. That's that. Those simple x cubed.
advance that into extras. So that's the last but this is really amazing. So this so I would recommend you are differentiating this thing, by the smaller group, just like it's what should that actually have? 1/4 part is wrong. But where was that solution? So it's negative, so that's just the exponential orbit. I don't know what else is happening. Hey, fun? Cool. Alright, so good. What's 2/3 minus 1? Otherwise, now you got to go downstairs. Cool. Go downstairs. And what's the derivative of 1x? 1. What's the derivative of any constituent? You help. Everything's good except for this term. So you should start here. Yeah. What's the answer? So 1/4 part is wrong. Where's the next one? Every time.
I wanted to do
So simplify these discrete fractions so that it's a singular x to something. Like less than x.
Okay. Yeah, whatever that's.
Oh. I would recommend the right fractions vertically instead of diagonal. Because if it's diagonal, I'm not really sure where the x is. But if it's vertical, then it's going to be. That's really next to the one half. This one won't be different. Ours turn different. But then you gotta throw them downstairs. So you gotta fix exponents here, 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 and throw them downstairs. Cool. Throw them downstairs, throw them downstairs. The same. Yeah. Like that thing, that's kind of in the back up. I would recommend the same thing as your rows. Instead of writing fractions like kind of horizontally, diagonally, writing like that so that there's no confusion about where this thing is. You have to divide out the fraction. So you know how you're distributed by one, you distribute by dividing. Everybody gets divided by this. Then you can now x2 check x1 and x2. He has what's 1 half minus 1? Yeah. So that's good. X goes in the denominator. X becomes hot. Let's do this minus 1. This is
All right, let's go over stuff. So, before we can differentiate number one, what has to be done with the first term? Anything before we differentiate? Nothing. It's cool. What has to be done with the second term? Make it look better. How is it going to look when it's better? 3x to the negative 2. This third term is going to be plus what? 3x to the 1/2, because square root is a 1/2 power. This next term, same sort of thing, but a third root of x squared is an x to the what power? 2/3 power. This next term, same sort of thing, but also in a fraction. So this fourth term is kind of a combination of the second and third terms in terms of how you rewrite it. This is going to be 3 and then what? Negative 1/4. So not just 1/4, that would be if it were 3 times 4th root of x, because this is 3 over 4th root of x. The x is in the denominator, so the exponent has to be a negative. This is cool, this is cool. Now you can go through and differentiate each term. What's the derivative of your first term? 6x. We have f prime of x now equals 6x. This guy becomes negative 6x to the negative third, because negative 2 minus 1 is negative 3, not negative 1. This next term becomes 3 over 2, then x to the negative 1/2, because a half minus 1 is negative 1/2. This next term becomes negative 1/3, because 2/3 minus 1 is negative 1/3, and 2/3 times 3 is just 2. This next term is because negative 1/4 minus 1 is negative 5/4. And the x term becomes, and the 3 term becomes, goodbye, 0, poof, it's gone. So you got to be good at subtracting 1. And then anybody that has a negative exponent just jumps into the denominator of its own term. So 6x is done. 6x to the negative 3 becomes minus 6 over x cubed. Here, the x runs into the denominator and you have 3 over 2x to the 1/2. Here, same sort of thing, 2 over x to the 1/3. Here, the x runs into the denominator with the 4 and you have 3 over 4x to the 5/4. And then the 1 is cool. So that's how that would look at the end. Yeah. Or a minus. Probably have one. Like if you stop here, you're not wrong. You're just incomplete in terms of making it look nice. For number 2, walking around, people who got to it look pretty good. What do you have to do before you can differentiate with number 2? FOIL, expand it out, distribute it out. When we distribute this out, what do we get? X squared plus 6x plus 9. And what is this guy's label? Still f of x. You have not differentiated yet because you haven't done a power rule. You just did some algebra. Now you can differentiate, and we get what? 2x plus 6. So you might look at something like, I can't differentiate that, but I know how to distribute. And then it's like, oh, that's actually pretty easy. This one is actually real similar in terms of the very general process. You also need to distribute here, but now you're distributing division. So some people went ahead. I saw a couple different methods. I saw some of this where you broke it up into 3 fractions, x squared over x to the 3rd, and x to the 4th over x to the 3rd, and 1 over x to the 3rd. That's fine. I saw some other people bring x to the 3rd up and turn it into multiplication by x to the negative 3rd, and then distribute that through. That's also fine. Whatever makes you happier. Just make sure that you then know what to do with either of these. In either case, when you then rewrite again, what's x squared over x cubed? Or what's x squared times x to the negative 3? What would I do with these exponents? Subtract them, and I would get x to the what? Yeah, you add the exponents. Or in this case, you subtract the exponents. So when I do x to the 4th over x to the 3rd, or x to the 4th times x to the negative 3rd, I'm going to get x to the 1st. And then 1 over x to the third, or 1 times x to the negative third, is going to be x to the negative third. Now you can differentiate each term individually. And you have f prime of x is x to the negative 1 becomes negative 1, and then x to the negative 2. X to the first becomes 1, and x to the negative third becomes, negative 3x to the negative 4. And then, where you have a negative exponent, throw that x in the denominator. So you'd have negative 1 over x squared plus 1 minus 3 over x to the fourth. Now, walking around, some people are in the habit of writing your fractions on a kind of a diagonal slant or even horizontally. That can lead to issues. If you look at like number 24 from the homework, I like the way it's written vertically. It leaves no room for confusion. If you wrote it like this, negative 15 over 8x to the fourth, now there's confusion. Where's the x to the fourth? There's room for interpretation there. I don't want room for interpretation. I want something real clear that I can read and know what you meant. So please get in the habit of writing your fractions vertically, especially if the denominator if the numerator or denominator involves multiple factors, like a number n and x. It's good to write it like this, so that, like this is just confusing. I don't know what you mean. So I should have written this fraction over here as negative 1 over x squared, vertically speaking, to just avoid any possible confusion. All right, last thing, what's the derivative of sine of x? So what's the derivative of 3 sine of x? 3 times cosine. Also, what's the derivative of cosine x? Negative sine. So what happens with this whole term? It becomes positive, because you have a negative sign times a negative 3 is positive 3 sine of x. Also, any trig function must always have something in it. So like this is not a thing. But you can't have 3 sine. It has to be 3 sine of something, usually a variable, theta, x, t, something's in there. That's cool. That's not. So if you get done in like 3 cosine plus 3 sine, I'm going to say sine and cosine of what? There's got to be something in there. Oh, it's of x. Yeah, let's put that in there. See, that goes down. Any follow-up with any of those things? After being dragged through this for a few days, how are you guys feeling about just, here's a function, differentiate it? Yeah, you get more practice over the weekend. Your homework over the weekend is more of this stuff. But, because I'm getting bored of this, let's move on and look at something else. Like, let's do something with it. Where's the eraser? Find points where the tangent line is horizontal.
Could you move the camera?
Okay. If you insist. All right, here's a function. This is number 54 out of the textbook. F of x equals root 3 times x. Notice where the x is not. Plus 2 cosine x. And so that we don't have infinitely many solutions, let's limit ourselves to between 0 and 2 pi. So if we want to find out on any graph ever where is the tangent line going to be horizontal? Think back to the warm-up. If the tangent line is horizontal, what does that mean about the slope of the graph? Slope is 0. And if the slope is 0, what does that mean about the function? Or rather, its derivative. It's 0. So the slope is 0 if you have a horizontal tangent line. By extension, that means the derivative is 0. You should go, Chris. No. All right. You had a game yesterday? No, that's good. Love this up. Wake up. This is important. So, if your slope is 0 because your tangent line is horizontal, then extension, the derivative is 0. So, what do we got to do with this function? Find the derivative. Go ahead, find the derivative. Take 14 seconds, your own clock. Yeah, I have to stop one. Got an extra 28 hundredths of a second. Mohammed, what's our derivative? 1 plus 2 sine x. Does anybody want to argue with Mohammed? Raisa. So Raisa saying root 3 minus 2 sine x. Does anybody have something else you'd like to throw out? Rachel? 1 minus 2 sine x. You're kind of a combination of Mohammed and Raisa. Ahmed? Say that again. 3 divided by 2x to the 1/2. And that's it? Okay, minus 2. I was going to say, you do something with that, please. All right, minus 2 sine x. Anything else? All right, let's vote. We have 4 options. Let's see if democracy really works. Who's going to vote for option Mohammed? Not even Mohammed votes for option Mohammed. What is this? All right. We'll vote balance here. Who's going to vote for option Raisa? 1, 2, 3, 4, 5, 6, 7, 8. Who's voting for option, I forget who this was, Rachel? Looks like 3.5 people. George is vacillating back there. And who's voting for option Ahmed? 3. And that accounts for less than half the class. Cool. Thanks to the rest of you for playing. All right, so, see, this is why democracy doesn't work, because not everybody votes. Go vote. Unless you're going to vote for the wrong person, then don't. So, what? Are you allowed to say that? Say whatever I want. Root 3 times x. All right, where's the x? Is the x inside the radical? No. So what's this root 3? Is it a constant term, or is it multiplying the x? It's multiplying the x. So this is like a coefficient. If we had 3x, what would be the derivative? 3. And if we had 5x, what would be the derivative? And if we had pi x, what would be the derivative? So if we have root 3 times x, what's the derivative? Root 3. So nope, and nope. And is the x inside the square root? No, okay, so no. So that leaves us with this. Now we got to determine, was everybody wrong, or was at least Raisa correct? What's the derivative of cosine? Negative sine. What's 2 times negative sine? All right, cool. So, yay! A plurality voted for the right thing. Democracy works after all. All right, so we have root 3 minus 2 sine x. That is your derivative. Any questions with that? Now, because that took a while, let's remember. What are we doing again? Yeah, finding out where the tangent line is horizontal. So now what do we do with a derivative once we found it? Set it equal to 0, because the tangent line is going to be horizontal when the derivative or slope is 0. So you found them, now set them equal to 0, and solve. In order to solve this, first you want to isolate your sine of x, and then backwards unit circle. Hooray. Isolating sine of x, what are we going to have? Sine x equals what? Root 3 over 2. And then unit circle time. Bum, 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 bum. We love unit circle. No, we don't. All right. So in unit 1, this place, quadrant 1. And sine is having us look at which coordinates, x or y. Y. What's sine is 0. On the unit circle, like this is the y coordinate. Y is how high? Y high, right? So y is how high? How high are we? 0. Okay. And then you count up. So what's this? And then what's this? And what's this? You guys fill my soul with joy. So what's this angle? What's this angle down here? And what's this guy in the middle? Right. So the angle is pi over 3. Now that's just quadrant 1. Where else besides quadrant 1 is sine positive? Quadrant 2. And what's our quadrant 2 version of pi thirds? 2 pi thirds. Ta-da! Are we done? No. Hey, good. Why not? We're finding. What are we finding? Read. Points. We're finding points. Yay, reading. We're finding points. Have we found points yet? Well, we've only found x coordinates. We found half of points. You need a full point, x comma y. So have pi over 3 comma something and 2 pi over 3 comma something. How do you find these points? The y's? Plug these into f of x. So f of pi over 3 equals root 3, oh yuck, times pi over 3 plus 2 cosine of pi over 3. I'm regretting this now. Do you want to clean this up? Me neither. All right, that's just going to be pi root 3 over 3. Great. This thing, what's cosine of pi over 3? Half. What's 2 times a half? Can you simplify this? Not in any meaningful way. All right, there's your y coordinate. So we have pi thirds comma this ugly. Pi root 3 over 3 plus 1. Do the same thing for 2 pi thirds. We have root 3 times 2 pi over 3 plus 2 times cosine of 2 pi over 3. And guess what this first thing is going to look like? 2 pi root 3 over 3. And what's cosine of 2 pi over 3? Negative 1/2, because cosine of pi over 3 was 1/2, and 2 pi over 3 is in quadrant 2, where cosine is negative. What's 2 times negative 1/2? Negative 1. So this ugly y coordinate is 2 pi root 3 over 3 minus 1. And there's the points. All right, so finding the points where a tangent line is horizontal, major takeaways is tangent lines are horizontal means the slope is 0, means the derivative is 0. So find the derivative, set it equal to 0, solve for x, and then pray that the y coordinates are not ugly. And probably while you're also at it, pray that you not have to deal with the trig function in the middle of this. We'll do more of this on Monday. Are we out of here? Do more of this right now. I was going to introduce K problems, but we'll do K problems on Monday instead. Say again? Here you go.
Oh, wait,
What do you mean by a K problem on Delta Math?
yeah, Friday, Monday, K equals
All right, make up an example for me. So they give you a function.
It's a piecewise function.
Oh, it's a piecewise function. That's not what I have in mind. So they say, here's f of x equals, right? And is k somewhere in here? It's like kx plus 3 and x squared minus k. And this is for like x is...
Like for the separate.
Oh, okay. So like x is not 0, and then x is 7. And this is k, and then this is like something else. And we want f to be continuous. So make f be continuous. Right? Okay. So we want to find out, what does the k have to be? If this piecewise function is going to be continuous, we need the separate pieces to do what? Equal each other at what x value? 7. So you look over here and say, okay, the place of possible discontinuity is here. So let's make top equal bottom at this x value. So we say top equals bottom at, in this case, x equals 7. So bottom is k. Top is x squared plus 9. In this case, 7 squared plus 9. What's 7 squared? 49 plus 9. K has to be 58. If k is 58, these two pieces connect. We're continuous. Ta-da! So that's the sort of thing that you're doing with that. That's not what I meant by a k problem that we'll do on Monday. Those are much more fun. But your homework over the weekend is more of, here's a million things, differentiate them all. Get practice with the differentiation so that it becomes like you sleep at night and you close your eyes, and on the back of your eyelids, you're just seeing derivatives. And it'll be so wonderful. Bad shot. Next week, I'm thinking Thursday, you're going to have a quiz on chapters 2.1 and 2.2. So something to look forward to. And then on Friday, you won't have a quiz. And then you'll have spring break.
I came in late, so you didn't ask for my homework.
Oh, right, yes. You did not do it?
I did.
You did do it. Okay. But you did not do it the previous night.
No.
And if you have it,
It's a
I'd
thing,
like
I
it.
was gonna get myself.
And if you don't have it, please
Can I
hand it
show
out.
it to you tomorrow?
Yes. Well, no.
No?
It's Monday.
Oh, they didn't email me. Can I email it to you?
Yeah. And they'll
I'll try
ask
to
for
email
it.
it like earlier.
Yeah, email it, but I'm not gonna. I'll look at it on Monday morning then. Yeah. Who's got AP tests in May? Oh man, that's a lot. Awesome, that's good. What AP tests are you taking? Chem, physics, bio, psych, gov, A push, Euro. Yeah, lit, lang. Any language, like foreign language? No? Okay. So I'm going to be missing anywhere from 1 to like half of you throughout May during AP exams on any given day. Okay. I'll ask in advance of like, as we get into May, my AP exam is May 9th, so I'll ask you guys what it is specifically. Because it was partially correct. There was something that you either missed that you should have included.
Exactly. I have water bottles in here, so what I'm gonna do is when I get to chemistry,
Or,
I'm gonna put them
yeah,
all
there's some nitpickiness that was going on. And if you look at the redness on the feedback that I gave you, that's probably what it is. Don't feel special. I give that to a lot of people. Yes, sir. Do not come after school first. I was here
That's why
late
you're
last
supposed to
night.
talk to your partner.
I
That
was
way
here
it gets less boring.
yesterday from
It gets less
about
boring if you talk to your
7:15
partner.
until 6:30.
Huh?
I've been fighting a cold for a week.
Yeah, it was really boring.
I did not sleep well last night. I want to not be here. Do not come and see me after school.
Same. Okay. Could you help me solve this for
Ew.
T? Yeah, this is what your brother's making me do.